Never good. That's what I was gonna say. Never a good idea. It's a trap. After a couple drinks in your system, you're like, oh, I'm gonna play a couple rounds.
So they walk out of the dome.
Don't do it.
Oh, I can play with 2 hands. Why not?
No.
There goes $30.
Yeah, exactly.
$4 to take it out of the ATM.
Yeah, no, exactly.
Is there?
I went to a couple things.
Sorry, just how are you going? Oh, okay.
Really good time. Yeah, it's a lot more logic. Yeah, a lot more hardcore.
They always do for that, like the corporate money there, like the more bucks.
Yeah.
And then I guess when they bring it back, there's a lot of options.
Yeah.
He's been like, if you set up the game, it's so rowdy.
Yeah. I was always sitting in the I got this ticket. Okay. It's not bad. You get a pretty good view.
Yeah, it's just a
Oh my god, sorry.
I don't know how like there are gets up there. There's always someone that falls.
Yeah.
There's it's like that 30 step all the way up.
Well, I haven't talked to Diana. Okay, hi everyone. So I'm going to start now. Okay. So today is the review session for the final exam for COMM 204, Operations of Logistics. So today our review session will be in 5 sections. The first will be on forecasting. The second is inventory management, and then more inventory management. And then the news vendor problem, as well as just general supply chain management facts. So we'll first start with forecasting. So forecasting is basically the process of predicting a future event. It's the underlying basis of all business operations, such as for forecasting production, forecasting demand, forecasting inventory, forecasting HR, and forecasting how much facilities you need, for example. So for forecasting, there's basically 3 major problems that you can face. One is just the simple moving average method. One is the weighted moving average. And then the last, we have the exponential smoothing. So that's basically covered by these 3 questions here. So I'll give you guys, say, 10, 15 minutes to kind of look over these questions and try them yourselves.
Oh yeah.
Why is your charger so awkward? Can I change this?
Yeah.
Did you hear my message?
Oh, it's spam at this point.
Oh, what the heck?
It just so that sometimes I know it's optional, it's really, oh, I don't care, but sometimes like I would never suggest reading this and something's not taught.
Yeah.
I can look at this and actually don't know.
Dude, the cheat sheet is so colorful. I want to see it.
The way you started.
Oh, it's after me.
But when you
How come there be so much stuff?
have like an hour like looking at it.
Why are we looking at that?
Because it's not what you said at all.
Oh, really?
No, they have safety stuff.
It's not as scary. Like you just make sense to kind of like go where you get it.
You're so proud.
But stuff down. You kind of take a second to let it
It's nice, but it's like
oh,
there's so much
this
to
type
talk
of that.
about. I don't know
Okay.
Well, that's because there's not yours. You never get paid it.
Yeah. Yeah, so I see. But I don't think it's a lot of subjects.
How do you think we realistically do?
I was wondering like how.
Because like I don't want to like say what I need. Yeah. That's
Yeah, it's a good. I'm doing that. He puts them out of order though, which is kind of frustrating. But yeah, the office correspond to literally the class number. So instead of being like lecture 1 to 10, it'll be like the class 1, class 2, class 4, class 5, class 1. Yeah. So they're out of whack. It's 8 office. Yeah. Do you keep story things? Or do you have yeah. So he's gonna do a little one question. So discourage people from talking, so just tell them, no, you're wrong. So like, oh, okay, I tried.
Did you miss
Starts
it?
bringing pictures to class of people, and just drop on project, put them on projector. He's like, oh, you look up here, like, what did you get class? It's like, I'm gonna answer the question.
Okay, so, wow, but I just wanted to eat literally. Oh yeah, of course, yeah.
Thank you so much.
What's your email?
Morgan, you have it.
Which gives
The ball, like a cardboard box, $2. I know. What's the black? No, but I like the
Yep, EN.
Yeah.
At a lump. WBC.ca. Thank you so much.
So like it's like a class. Yeah.
For sure, there's like, we should look at this, yeah.
Yeah, so I think it's gonna be the same deal as the material.
Oh, okay.
Especially like my spaghetti picture.
And this is going to open.
Yes. What is your name?
Oh, yeah.
Rhea? I'm Ben. Nice to meet you. Finals? Lindsay doesn't screw us either.
Even though we're chatting, I mean, for staff class,
That's just yeah. I know. Like, it's good job. When they said they're doing it for economic to Microsoft conference again. Like sometimes when they like more stuff, it might change the comprehension, but it is
But like
exactly
if
that.
you get caught, you're immediately fired off.
As long as I have every answer here, I flip to it.
But union, so they're afraid of you going back into their time.
Not if you break
that you won't fire for just
Yeah, and then are you? Like the last year, so like did Kristen's one either. Whatever, like why did you do this? So we say don't ask you like about calculations. Just about like the managerial.
So when are you working next? I'll give you my uniform.
what's that?
Or yeah, so understand the rationale.
What's that?
So I think it's probably the big takeaway. But of course,
Can I just give you
the answers.
Like I haven't resolved.
They're helping us at work. Yeah.
We'll go to Diana's closer.
Honey, you admit that you're going to do it.
Okay, he lives way too far.
He's closer to civilian stuff than you. Okay, just depends. Civilian of what? What civilian?
I said that. So like they'll probably end up taking ship the protection.
Well, she doesn't. She's kind of shipping. Just us.
Yeah, she had such a trouble.
I feel like this is worse than first.
No, we talked about this because everything's new. Yeah. But last year was he's taking notes, I see.
She's
But
minimizing
I'm thinking
everything.
how much notes we need. Because I thought everything yeah, I don't know. I'm just gonna
I'm using size 6 phone.
insane.
Alex.
Yes. she's literally typing like at the page all over. Like, I'm gonna take this out. Depending on how much data and stuff. Like, if I have like so much space at the end,
It's annoying to get stuff back in.
yeah,
Because you have to restart.
yeah, I'd rather just take it out. True.
Delete and then put up with like another slide.
Well, what you can do is you can also use like for like font. But like, how much of this? Is there any? That's free. That's all post, right? That's free. Post. Free.
Okay, so I'll start with doing the first question.
Oh yeah, that's just
Okay,
Yeah.
so the first question, we need the weighted moving average method. And this method, all you have to remember is that the most recent periods always have the heavier weight. So if they give you like a range of weights, you can just arrange them in order, and then the most recent have the heavier one. So the formula for this is the sum of all the weights for how many periods you have. So say we have n periods times the demand in period n. Zoom in. Okay. Over the sum of all the weights. Okay, so for number 1, our answer would just be, so the weight times, so February will be weighted the least if you want the May data, and then you have 3 times 47 plus 4 times 43, with April being weighted the most, so it has the 4 over the sum of the weights. So this would be equal to 44.1, which is me. Okay, so for number 2, we have we're using the moving average method. So this is just a series of arithmetic means. And the formula here is just the sum of the demand in previous n periods over n. Okay, so the question we have here is daily sales of craft at a local Starbucks are in the table below using the 3-period moving average and the 4-period moving average method. Compute the MAD for each forecast and then forecast day 8 using the more accurate method. So I just want to start with the fact that MAD, it means mean absolute deviation. And it indicates that on an average basis, how many units is the forecast off from the actual forecast. So, okay, so MAD equals, if you take the absolute of the forecast error, which is the actual forecast minus the actual number minus the forecast, and you sum all of them over the number of periods, that's your MAD. usually, I know the prof also introduced the mean square error, the MSE, as well as the mean absolute percent error, the MAPE. But in this case, when you're comparing between methods, we usually use the MAD for comparison. Okay, do you guys still need this? Okay, so for number 1, for number 2, I made this graph just to make it easier for us to see. So we know that, sorry, this should be day. We know that there's 1, 2, 3, 4, 5, 6, 7 days that's given to us, and the actual sales is also given. So we have 17, 21, 27, 31, 19, 17, 21. And we want to forecast day 8. So we'll put 8 here. Okay, so using the 3-day weighted moving average, we're simply going to sum these 3 here and divide it by 3 as the day 4 forecast. So that will be 21.7. And then we'll just be going down the list. The next one will just be the 21 plus the 27 plus the 31 divided by 3, which will equal 26.3. And just going down the list, we'll have 25.7, 22.3. So you're always taking the 3 previous ones and divided by 3. Okay, and the error is always the forecast, the actual minus the forecast for the error. So what we do is we just take the 31 minus the 21.7 equals 9.3, and note that it's an absolute value. So even if it's a negative number, it'll still turn out to be positive. So we're just subtracting everything here. 17 minus 25.7. So even though it's negative 8.7, the absolute value is positive 8.7. So it just makes it easier for us to compare. Okay. So the 4-day weighted moving average will be, instead of taking 3 numbers for the previous period, we'll be taking 4. So we'll actually start at day 5 because that's when we'll have 4 days of data. So we take 17, 21, 27, and 31, dividing it by 4 to get the day 5, which would be 24. And then we take 21, 27, 31, 19, so the previous 4 pieces of data, and we'll get 24.5. And then the last one is 23.5. And again, the error is just the actual minus the forecast. So this one will just be 5, 19 minus 24. And then 17 minus 24.5 is 7.5. And then 21 minus 23.5 is 2.5. Okay. So before we forecast day 8, we need to know which method is the better method to use. Is it the 3-day weighted moving average or the 4-day moving average? So what we need to do now is compare the MAD. So compute the MAD first for each of these methods and then compare it. So the MAD for the 3-day moving average, according to the formula, it's just the sum of all these errors minus how many periods you used. So this one would just be 9.3 plus 7.3 plus 8.7 plus 1.3 over 4. 1, 2, 3, 4. equals 6.65. The MAD for the 4-day forecast is the sum of these numbers here, divided by 3. So 5 plus 7.5 plus 2.5 over 3 equals 5. So we know that MAD, we always want the lower MAD because it shows that there's less deviation between the forecast and the actual. So in this case, we want the 4-day moving average because it has lower MAD. And so we want to forecast day 8 using this 4-day moving average. So what we do is we take the 31, 19, 17, 21 and divide it by 4, which will give you 22. So this would be
How did you get the 22?
the 22. You take so it's just like how you did the previous ones. So we took 31 plus 19 plus 17 plus 21 divided by 4. Questions? Okay. So now we'll be going over number 3. So for number 3, we're going over the exponential smoothing method, which is the third method for forecasting. This one is a bit more complicated than the other 2 methods. It's a form of the weighted moving average as well. So it usually requires a smoothing constant represented by alpha, which ranges from 0 to 1. And this one is better than the other 2 methods because it requires little record of past data. So, better. This requires. Okay, so the formula here is more complicated. It was just the new forecast, so whichever period you want to forecast will equal to the last period's forecast plus the alpha that you're using times the last period's actual demand minus the last period's forecast. question. Management wants to forecast the tonnage unloaded at a shipping company. The forecast tonnage unloaded for quarter 1 is 175. And the actual tonnage unloaded for each quarter is given below. Using an alpha of 0.1 and 0.5, compute the forecast for the rest of the 8 quarters. And they ask that which smoothing constant is better. So we'll start with using the smoothing constant of 0.1. So we're given 1, 2, 3, 4, 5, 6, 8 quarters, and we know that the actual is 180, 168, 159, 175, 190, 205, 180, 182. And we're given that the rounded forecast for the first quarter is 175. Okay, so we'll start with the first row. The absolute deviation is just what we did before. It's the absolute value of the error. So it's just 180 minus 175 equals 5. The forecast error is squared, so we're squaring this. It's 25. And the deviation times 100 over actual will just be 5 times. So it'll just be 5 times 100 over 180. So that's 2.75. So on the actual exam, if they ask for MAD, we're using this one here. So you don't need to calculate any of the other ones. If they ask you for the MAPE, the mean absolute percentage error, you want to use this one. And if they ask you for the MSE, you want the second one is actually the MSE is the mean squared error, so this one is actually the MSE. And then the standard deviation is the mean absolute percent error, so it's the MAPE. Yeah. But in this case, we're just gonna make it simple for ourselves because we're comparing the two alphas, so we're just actually going to compute the absolute deviation and ignore all of these because we're not going to calculate the MSE and the MAPE. So for the quarter 2, our forecast, according to the formula, will just be the previous period's forecast. So that is 175 plus the alpha, 0.10, times the previous period's actual tonnage, so 180, minus the previous period's forecast, so 175. And this will give us 175.5. And 168 minus 175.5 is 7.5. Okay, so moving down the list, quarter 3, it will just be the rounded forecast of the previous quarter, so 175.5 plus 0.1 over 168 minus 175.5. And this will equal 7. This will equal 15. 174.7. And by subtracting it, we know that the absolute error will be 17.75. So quarter 4, we'll be doing the same thing again. So it'll be 174.75 plus 0.10, 159 minus 174.75, and equals 173.18, with the error being 1.82. Okay, so I'm just going to give you the formulas for the rest. So we're always taking the previous one that you just calculated, 173.18, plus the alpha times the 175 minus the 173.18 equals 173.6, with the error being 16.64. So I'm just going to give you the numbers for the last bit here because it's just using the same formula. So I just want to save some time. 178.22. Okay. So again, we want to calculate the MAD for this method. So we want to sum all of the errors here, which will equal 82.45. The sum. So the MAD will just equal the 82.45, which is the sum of all the absolute errors, divided by how many periods there are. So there's 8 periods, and this will equal 10.31 for a smoothing constant of 0.1. So for the second quarter here, again, we know the numbers. We're just using a different constant. So 180, 168, 159. We know that the first, this is given in the question, that the forecast for the first quarter is 175. So again, we know that this is 5. So for quarter 2, we're taking the 175 plus the new smoothing average, which is 0.5, and then 180 minus 175, which will equal 177.5. So taking the absolute deviation of the error will give us 9.5. For quarter 3, we're taking the forecast for the previous period, 177.5, plus the smoothing constant times the 168 minus 177.5, which will give us 172.75. And the absolute deviation will be 13.5. Okay, so for quarter 4, we're just doing the same thing again. So this time it will be 172.75 plus 0.5 times 159 minus 172.75 equals 165.88. Okay, so I'll just give you the rest of the numbers again just to make it easier. 80.22. So on an exam, this will be pretty annoying to do because you have to calculate every period, but we do need to do this to calculate the MAD. So again, the MAD, we're just taking the sum of all of the absolute deviations, which is 98.62, and we're dividing it by how many periods we used, over 8, which will equal 12.33. So comparing this one with this one, for the different moving averages, we know that this one is better because it has lower MAD. Any questions so far? Okay, so we'll be moving on to the next section, which is inventory management. So there's just 2 questions here. So inventory is basically just a stock of an item or resource that is used by the organization to meet internal or external demands. So first, I'll introduce the first question. So you need to know there's 3 types of costs involved. The first is the item cost. So this is just how much you're paying for the product. So you can say it's the cost of goods sold. The second is the ordering or setup cost. So this is the cost of placing an order or receiving the good. You can also say it's the cost to prepare a machine or process the order. So for example, it's the cost of the forms that you have to use, it's the clerk's wages, etc. The third type of cost we have is the holding cost or carrying cost. So this is all the cost involved with keeping the order. So cost of carrying the inventory. So for example, this has a lot of like building costs, so building lease, insurance, taxes. So the ordering cost will be using the letter S, and the holding cost will be using the letter H in our equation. So a lot of the times, the system that we are using is called a fixed order quantity model. So this is different from the fixed time period model because the fixed time period model orders every time a time period is reached, but this one, it reorders the inventory when the reorder point is reached. So it is event triggered instead of time triggered. And these reorders are always in fixed amounts, so they're always the same amounts. And so for these types of questions, the economic order quantity will just be denoted by the formula. And the total cost will just be quantity over 2 times the holding cost plus demand over quantity times the setup cost. Okay, so the first question here will be using this fixed order quantity model. So you guys can, I'll give you guys 5 minutes to kind of try this problem. When the demand times the unit cost, right?
Yeah.
So you need it when like it's actually given to you how much it costs. But sometimes they don't give it to you. Like they only give you the holding cost. They don't tell you how much they actually bought it for.
Okay.
Yeah.
So you just assume that.
So the actual equation is actually supposed to add. You're supposed to add the purchasing cost, right? But sometimes they don't give it to you, so you don't know.
So you just assume that you don't have to do it.
Yeah, you just in this case. But in the next question, we'll be using it because it'll be given. Yeah. And I do just want to remind you that D equals the annual demand. So if they give you a daily demand, you do have to convert it to the annual. here it says the large consulting firm uses an average of 40 packs of paper a day. Each pack contains 500 pages. The consulting firm operates 246 days a year. Holding cost for the paper is $1 per pack, and it costs around $6 to order and receive a shipment of paper. So in this question, each pack contains 500 pages. Actually, doesn't really matter because we're only calculating per pack. So we know that demand is 40 packs a day times 246 days a year. So again, demand is annual, equals 9,840 packs a year. We know the setup cost is $6 per order. And we know that the holding cost is just $1 per package per year. So the optimal quantity to reorder, we know that this is the formula. So we'll just be plugging everything in. So 2 times the 9,840 times the $6 over the $1. So which is around 344 packs. For B, compute the total annual annual ordering and holding cost using your order size from part A. So we know that total cost equals Q over 2 times H plus E over Q times S. So we know that the quantity calculated from the previous question is 344 divided by 2 times the holding cost, which is 1, plus the demand, so 9840, over the quantity times the setup cost. And this will equal So for C, it asks, except for rounding, our annual ordering and holding costs always equal at the economic order quantity. Why? So I just want to draw a graph that shows the relationship between these costs. So this, on the y-axis, we have the annual cost, and then on the x-axis, we have the order quantity. So I'm going to draw a curve. This curve symbolizes the total cost for setup and holding cost. And then we have the holding cost curve, as well as the setup cost curve. So we know that at the minimum point of the total cost is always at the intersection between the holding cost and the setup cost. And if you equate the holding cost equation and the setup cost equation, you'll get this equation there. So we know that this is actually the EOQ. And this is the minimum total cost on the y-axis. So for C, we know that the annual ordering and holding costs are actually always equal at the EOQ because the optimal order quantity is found at the minimum point of the total cost curve, which is where ordering costs and holding costs intersect. So they do equal. So C is yes. So for D, the office manager is currently using an order size of 380 instead of the 344 we calculated before. So the partners of the firm expect the office to be managed in a cost-efficient manner, meaning that they want to minimize total cost. So would you recommend that the office manager use the optimal order size of 344 instead of the 380 packages? Justify your answer. So we want to first calculate the total cost of the 380 package that they're incurring right now. So the total cost for 380 equals the 380 over 2 times $1 holding cost plus the demand over the quantity times the setup cost, which will equal 345.37. And from the previous question, we know that the total cost for 344 packages is 343.63. So calculating the difference, we know that using 380 is actually just $1.74 more expensive than using the economic order quantity of 344. So I actually would say that I would not recommend that the officer uses or changes their current order size because this is so minimal. So that makes the 380 acceptable. Just write that here. Yes.
One question.
Yeah.
What would you consider as some amount that's outside of acceptable range?
The amount that's outside the acceptable. What do you mean?
What amount is like big and too cheap?
Oh,
Is it
okay.
like 1,000?
I would say if it's over 100, 200, depends on how many packs that you're ordering. Like, what's the difference in packs? So here it's 380 minus 344 is 36 packages, so that's not a big difference. I would say if it's over 100 or over $100, that would be significant. But a dollar is for sure not. Yeah. Any other questions? So we'll move on to number 2. So number 2 usually is another form of question. It's called the quantity discount models. So in this case, we are allowed a quantity discount of 25%. And we know that in each range of quantity, it'll be a given price. And this is, as you can see, this is often due to the fact that as quantity increases, the unit price will decrease. So that's the discount there. And so in this case, the EOQ will equal C. So in this case, we know the D and the S. The I is just the 25%. So it is the holding cost as a percentage of C. And then C is just the unit price. Which is given by these sections here. And we know that the total cost here will just be D over Q times the setup cost plus Q over 2 times the holding cost plus demand times the unit price. Okay, so first, we want to calculate the EOQ for every single discount possible. So for supplier A, we know that the EOQ from 1 to 199, so the first part here, will equal to 2 times 40. So the 9,600 is from the fact that expected annual demand would just be the 800 boxes per month times 12 months. Boxes per year. And again, it's critical to know that demand is always annual. So if you don't convert it in the beginning, you'll have mistakes throughout the rest of your calculations. Okay, so this is over. So the holding cost is 0.25 times 14. This equals. Oh, sorry. Sorry, the bottom equals 3. So this equals 468.43. And we know that since 468 is not within the quantity range here, we do have to change it, adjust it so that it is. So we'll adjust it to 199, which is the closest that I can get. So for the second EOQ from 200 to 499, would just be times 40 over 0.25 times 13.8, and this will equal 471.81. And for this, it is feasible because 471.81 is within the 200 to 499 range. For the last one, for 500 plus, we have the same thing, 2 times 40 over 0.25 times 13.6 equals 475.27. And again, since this is not within the range of 500 or over, we'll adjust it to 500, which is the closest that I can get. Okay, so we want to calculate the total cost for each of these. So the total cost for the first one, 1 to 199, will equal And note that we always use the adjusted number, so 199 here, plus 199 over 2, 14. So the 3.5 is just calculated by the 0.25 times 14, which is the holding cost. So for the second part, we have 2.249. So this one, since it is feasible, I just use the rounded. So I rounded 471.8 to 472. Plus 3.45. And 3.45 is just 0.25 times 13.8. So the first one equals Okay, so for the last one, for 500 plus, we have 9600 over 500, which is what we adjusted it to, times 40, plus 500 over 2, times 3.4, which is 0.25 times 13.6, plus 13.6, the unit price, times the demand, and this equals 132,178. So comparing these three costs here, we know that this one has the least. So for supplier A, the optimal order quantity is 500, and it'll be at a price of 132,178. Okay, so we'll be doing the exact same thing for supplier B. So calculating for B. So the ELQ for the first quantity range here, 1 to 149, will equal to 2 times 40 over 0.25 times 14.10. This will equal 4066.77. And since this is not in the feasible range of 1 to 149, we have to adjust it to 149. Next, from 150 to 349, the EOQ is 2 times 40 over 0.25 times 13.9. This will equal, and again, this is not within the range, so it's not feasible. We adjust it to what is the closest, so 349. For the last one, 350 plus. And since this is within it's over 350, it's feasible. So we don't have to adjust it. Okay, now again, calculating the total cost of each of these options. So total cost for 1 to 149 will equal. So again, this one, because the economic order quantity was not feasible, we used the adjusted value to calculate the total cost. And so times 3.525, 3.525 is just the holding cost, which is 0.25 times 14.10 plus 14 times 6. And this equals 138. So the total cost for 152,349 equals which will equal to 135.46.67. Okay, and the total cost for the last quantity will be 474, so we can use the actual quantity here. 40 plus. Okay, so comparing these three total costs here for the three different discounts, we know that the lowest is for over 350. So for supplier B, the optimal order quantity is 474, which is this one, at a price of 133,085. Okay. So the question here asks which supplier should be used and what is the optimal order quantity if the intent is to minimize total annual cost. So we see that here for supplier A, we had an EOQ of 500 at this price, and for supplier B, our EOQ is 474 at this price. So comparing these two prices, we know that supplier A is actually cheaper. So our conclusion is that use supplier A. And the economic order quantity will equal 500. Okay, any questions so far? Okay, so that wraps up the first 60% of the review session, so we can take a 10-minute break. So during this break, I think there's going to be a feedback survey that I hope you guys can fill out to reflect my teaching. Thank you. So we'll come back in 10 minutes.
But for us, I think it's cumulative. It's being more focused on the back half. We have to understand first what the
So you know range this one's
I don't know if you guys use it, ours is small.
yeah.
Oh, okay, yeah.
So what is the best
Even
that
stuff
you
like
can do that is closest to that? So that's the 199. Yeah. The best that you can do would be 500. Over 500, right?
Oh, yeah.
We didn't mark it in a
Oh, so you would adjust it because 500 would be
Oh, you just
closest.
added them all.
Yeah. Yeah, exactly.
This is like using, this is like
It's like the weight. He says the weight is like
What is this? Is this just like what's
so I guess the total.
That's what's
Oh, he was
for that. So for that, you know,
So for quantities from 200 to 400, like what?
yeah,
So everything was in that range.
No different.
yeah,
okay, now that range, the discount.
it's like the same stuff.
Yeah, so if it was higher, you would go to the next one. So if it was lower, it would be
I've never seen that.
I don't know.
Give it that? Yes.
Within
I was
these.
Yeah.
Oh, yeah.
Yeah.
Basically the stuff. Maria?
Yeah, so you're
Oh yeah. So that's I get that. They're saying basically the quantity, right? If you order between 100 to 490, that gets 13. So you
like the
try to get the correct, the optimal amount under that price, right? And then
so everything that I just
oh, 349. Well, you can only get that.
Oh, okay.
Oh, okay. So if it's above 199, you just go to 199. That's basically. And then with the total she was using for Q and to the
Okay, is it just here or just like your
yeah, EOQ. It's either EOQ if it's
Or it's maximum.
yeah, maximum or minimum. Exactly.
Perfect, thanks.
Like, if this was even hotter than my house.
I'm so used to like writing like computer management, right? And then like whenever I have to write over basic example.
It looks so right.
I do actually. I used to prefer more. I guess for these like I would prefer like math, but if it's like for example, I took HR a couple of years ago, and that's like very like
Graduate
qualitative, right? So it's like. So why am I writing? Why can't you just make it on the laptop, right?
And then they make you counting on it.
Yeah, exactly.
The opposite of a test that should be.
So it's how much
You're gonna count it?
No, I'm in
So
general.
it doesn't really.
Yeah, no, it's fair. I thoroughly dislike online tests. There's always something wrong. Usually that like goes back to questions not fully answered. Because you know, if you start typing, it says you answered the question, and then back at the end of the answer, you're like, oh, I didn't answer that correctly, but it says you did. So I prefer just having a piece of paper as like square.
Maybe we can
Yeah, you can mark down like.
But it's like this is
Cool.
Dallas is going to take me off this medical. Not the
Yeah, we don't need this.
What is it? If Dallas makes it to the Western Finals or something like that, Calgary is
Yeah, no, it's the Western Finals.
If they make it or if they win.
If they advance.
it's
Oh, that's actually not that bad. No, if they lose, it depends on.
I'm gonna study for mine here, so that's it. Like, have you done that?
Draft is pretty good draft.
Yeah, I think what they say is there's a top three,
Yeah,
and then there's everyone else.
so much
Like,
sleep.
it's not like it's a bad, and there's everyone else.
Dude,
It's the
I
top
slept on
three's
one,
really
and I
good.
yeah.
On a Sunday.
yeah, guys, you do.
A lot of Canadian teams this year too. All time, right? You have a good chance to
Okay, so
Well,
the chance of getting
it's not all that long.
retire.
But it's like mindset, like, when you wake up later, you're like,
Oh,
is there.
I'm surprised.
They said that contribution is definitely getting 61%.
Yeah, I hear
last
about
year.
that.
So have I showed you that?
Oilers get Matthews.
I swear.
That'd be such a good
There's
change.
several.
The thing is, I don't know. Like, I feel like they changed the rule. They changed it already, right? Like, I feel like they're gonna put some kind of you can only win like 5 times.
They changed it last year. To turn the Oilers, like the Oilers go ahead and win it. And then it was Bill Daly, the like, second in command.
Yeah.
Says, oh, the Oilers win it, we're gonna have internal discussions,
No
which
idea.
sort of
Actually, I'll
happens
ask
like you might remove it from the
Yeah.
package.
Oh, they can't.
No, they can't. But
No, you
it is
can't.
getting a bit ridiculous.
No. You were
I mean,
sleeping.
The thing I feel bad is like
I'm
it's kind of common. You have your stem on like you have like Phoenix and you have like Bubble intentionally tanking. Chase them to they want to be good, but it's like they suck anyway. But it's like Buffalo, they try to suck.
Oh yeah, so that's like kind of crazy that we won an advantage, so that's something I'm fine with.
I'm hoping like Toronto or
Did Vancouver go push just
20,
ahead of
20, they finished 27. The last place is
It's Toronto.
Toronto, Edmonton, Vancouver.
Oh, it's Vancouver's third worst. Okay, I think we're fifth worst.
Yeah.
Okay, that's
And
interesting.
then there's Columbus after us, and then it's Calgary.
Yeah, that makes sense.
Winnipeg's
Okay,
pretty up there too.
I think they're right after us. We might hit this level.
Yeah. The Canadian teams have like a 70% chance of winning first overall, I think.
That's pretty nice. So that means Columbus is
Yeah, exactly. I'm hoping we might stay. Like Vancouver never even had a first overall pick. So in their history, so it'll be nice to
Maybe a marketing one, but
We'll see,
it's like,
yeah.
like,
Or I guess.
like. I wonder what Edmonton's gonna do though if they get top two.
oh, I know, I did that.
They like the thing
That
is
sounds,
like
that sounds cool.
they're not gonna get paid for those trades. Like they're not gonna get fair value.
Yeah.
When you look, there's a really like lazy thinking is that Matthews is a Phoenix boy, so that Arizona's gonna move up, but they keep saying they won't.
Yeah, and they won't. It's not like they're gonna give up on him. Like if you don't, they need defense other than they want.
Yeah, exactly. The thing with Edmonton is you know they're gonna trade at least one of their first overalls. Like yeah,
Oh, they're
Paul's
trading.
gonna go.
Yeah.
You look at Nugent Hopkins.
Okay, so I'm gonna start with the third part, which is more inventory management. So this one has to do with calculating how much you order given the safety stock that you have. So for number one, just gonna give you a quick review. So this one again is the fixed order quantity model. So again, we're ordering when your inventory reaches a certain point, and your order is always going to be constant. So for this one, the reorder point will always be D. So this part here, L is lead time in days, D is demand. So this is just demand during lead time. And SS means safety stock. Safety stock. And it is calculated by this formula here, which I'll explain later on. Okay, so in this case, the Z is just the standard deviation, the number of standard deviations for the desired service level. So service level is the probability that demand will not exceed supply during lead time. So the probability that you will not have a stock out. And this portion here, the standard deviation, is just the standard deviation of demand during lead time. And this will be given to you. So for the first question, Safeway sells almonds by the kilogram. Historically, Safeway noticed that daily demand is normally distributed with a mean of 80 and a standard deviation of 10. Lead time is 7 days. what is the order quantity that would provide a stock out risk of 10% during lead time? So I think he'll give you the fact that if there's a stock out risk of 10%, your service level will be 90%, and the Z here will be 1.29. So usually, I remember when I was taking the course, he would just give you the Z. Yeah. So ROP will just equal the demand during lead time. So that's 80 times 7 days. Here. Plus the safety stock, which is just the Z, so 1.29, times the standard deviation. So the standard deviation here, I think your prof actually puts the 10, like he square roots the 10, so it'll be times 10 squared here. So it's the same because this one's just factored out. So this one would also be 7 times 10 squared. I'll give you the same answer. So this would equal kg. Okay, so for number 2, in the summertime, demand for ice cream at a local 7-Eleven can be approximated by a normal distribution with a mean of 14 kilograms and a standard deviation of 2.5. But note that this is per week. The new manager desires a service level policy that has a 95% probability of non-stocking out. Lead time is 2 days, and the store is open 7 days a week. So something that you have to know is that lead time is in days, but the standard deviation is given per week. So something we have to do in this case is just to divide it by 7, which is the number of days in a week. So I'll show you how that is done. For A, if a fixed order quantity model is used, what ROP would be consistent with the desired service level? So this is just the same formula as number 1. So here, ROP is just demand during lead time plus the Z times the standard deviation. So in this case, demand is 14. What we do is we divide that by 7, which gets you what's the demand per day, and then times 2 days. Plus the Z score in this case for 95% probability would be 1.65. So plus 1.65 times 2.5, which is the standard deviation, over the lead time divided by 7, which is per week. So again, this could be factored into this area. So it would be 2.5 squared over 7, but I just took it out. So it's the same thing. So again, we divided it by 7 because the standard deviation is in per week, but we want it per day because we have to times it by lead time, and lead time is in a per day basis. So that's why we divided it by 7 here. And so the answer for this ROP would equal 6.2 kilograms. For B here, it's a bit more complicated because we're using a fixed time period model. So like I said, the difference between the fixed order and the fixed time period model is that the fixed order quantity you order at a constant quantity when the ROP is reached. But for fixed time period, you order at equal time period intervals. So say after every 2 weeks, you would reorder instead of when the reorder point reaches like 5 kilograms or something. So fixed time period. Order placed at the end of a period, a certain period. And for these ones, the ROP is calculated by the formula. Okay, so I'll explain what's here. So the I here is the inventory level at reorder point. So how much you have on hand when you're reordering. This part here is the expected demand during lead time plus the interval that you're waiting for, so plus this fixed period. So T, the T in this case, is equal to this fixed period, which is the time between orders. And L is lead time. So the difference between L and T is that lead time is the time interval from when you placed your order to when you received your order, but the T here is when you received the order to the next time you placed your order. So then the standard deviation at this time would just be the standard deviation of demand during T plus L. Okay, so for this question here, IOP will just equals, the demand is 14, and again we divide it by 7 like before, times 2 plus 5. So the 2 is the lead time in days, the 5 is the order interval of 5 days given in the question. And we know that the z-score is 1.65 times the standard deviation of 2.5 over 2 plus 5 over 7. So again, this part could also be 2 plus 5 times 2.5 squared over 7. So again, we're converting this to a per day basis because the 2.5 is given in weeks. And then something we have to note here is we do have to take out how much supply you have on hand at the reorder point. So we have to minus 4. And this will give us 14.125 kilograms as the reorder point.
Sorry, why do you minus 4?
Minus 4 because that's how much you have at the reorder point. Yeah. Any questions? I know this one's a bit complicated because we had to divide by 7. Okay, so moving on. have the news vendor problem. So the news vendor problem is designed to decide how much of a product to order when the product is sold over a short selling season with variable demand, and there are no additional opportunities to replenish your inventory. So there will be no reorder point. So just some background about this question. We want to first calculate the under coverage cost per unit, which is denoted by CU. And this is equal to the benefit of selling one unit or the opportunity cost of not ordering enough units. So it's the under coverage cost. And this is equal to the selling price minus the manufacturing cost. Next, we want to calculate the over coverage cost. So this is the cost of ordering one more unit than what you should have ordered had you known demand. So you have ordered more than you wanted. And this is equal to the manufacturing cost minus the salvage value. Next, we want to calculate the critical ratio, which is just the CU over CO plus CU. So to find out what is the optimal order policy or order quantity in this case, we want to have a cumulative probability that would equal this ratio, whatever you got there. And that would be the demand that you would want to order for the amount that you would want to order. So note that if the critical ratio falls between two cumulative probabilities, falls between two values, choose the quantity. Choose the greater order quantity. Okay, so given what is said here, I'll give you guys 5-10 minutes to work on just the number one, just the one question here. It's going. I actually just finished.
Kind of dense. And like having all yeah. And then that's very good.
Yeah.
Oh, so
Maybe I'm wrong on this.
what do you think?
Maybe what I think it was near because
I keep looking at
Yeah.
True, I have some nuts.
Yeah.
I put like,
Kim.
like I'm thinking of leaving, but like usually.
No, the second part is
Was it more than you
Oh, good God, 3 goals.
Where's
What is it, 5-2?
I mean, the series.
Oh, 3-2.
Oh, yeah, sorry.
Check the paper.
Yeah, it was
Okay, so
Oh, yeah, it was Saturday. Yeah,
okay, so first for this question, we know that a bakery-based strawberry tarts overnight each tarts cost $3.50 and sells at $5. The owner is proud of the freshness of the baked goods, and therefore unsold tarts are donated to a local food bank for no charge at the end of the day. So from this sentence, we know that the salvage value for unsold tarts would be 0. So we first want to calculate the overcoverage cost, and this is just the manufacturing cost minus the salvage value, which is 0, and it would just equal $3.50. Next, we want to calculate the undercoverage cost, which is the selling price, $5 minus the manufacturing cost equals $1.50. And the critical ratio is just the undercoverage cost over the sum of the overcoverage and undercoverage cost, and it would equal 0.3. Okay, so what are we going to do with this critical ratio? We want to calculate the cumulative probability. So given the number of tarts, 3, 4, 5, so on, we want to find the cumulative probability that this would be under or over, so around this range. Okay, so we know that 3 tarts, the cumulative probability is just 0.05. At 4 tarts, the cumulative probability would just be the 5% times the 12%, plus the 12%, so it's 17%. At 5 tarts, the cumulative is the sum of the 3, so it's 37%. And note that the critical ratio falls between those two values. Tart number 4 and 5. So like I said before, when the critical ratio falls between two cumulative probability values, we always pick the larger quantity. So here we would pick 5 tarts. So order 5 tarts. question asks, what is the expected daily profit that the bakery realizes with the 5 tarts that you want to order? So the profit equals the total revenue plus the total salvage value minus the total manufacturing cost or purchase cost. So in this case, it would be 5 tarts times the total revenue is $5. Oh, sorry. So you would actually need to calculate for each of these, everything that's under the 5 as the total revenue times the probability. So it would be 3 tarts times the probability of 0.05 and then times the $5 selling price plus the 4 tarts times the probability 0.12 times the $5 plus 5 times 0.2 $5. And then since the salvage value is 0, so we would ignore that, minus the total purchase cost. So I actually got a negative number here, so there would have a negative profit. Okay, so now we'll be on this last part of the review section, which is just some qualitative materials that you might need about supply chain management. So supply chain coordination is basically when all stages in the supply chain, they work together, and this usually results in more profit for the supply chain. But there's something called the bullwhip effect that affects this coordination. So, number 1, what is the bullwhip effect and how does it relate to the lack of coordination in the supply chain? So the bullwhip effect is when there's fluctuations in the orders along the supply chain as orders move from each stage, so from retailers to wholesalers to manufacturers to suppliers. So these are fluctuations in orders. And it occurs when each member of the supply chain, so wholesalers, manufacturers, have a different idea of what the demand is and tries to solve the problems from their own perspective. So each supply chain manager demand is So because everyone is thinking about how to solve the problem from their own perspective, the demand variability actually increases as you move up the supply chain. So demand. As you move up the supply chain. And as a result, small changes in demand can result in large variations in orders. Small changes in demand lead to large changes in orders. So this just shows the lack of coordination. So for number 2, what are the causes of the bullwhip effect and how can you counter it? So causes, I'm just going to write this in plain form, includes neglecting an order in an attempt to reduce inventory. So neglecting order, or lack of communication in the supply chain. Demand forecast inaccuracies. Ordering large batches. Large batches to reduce cost. Or price variations such as discounts that you're giving to customers. So all of these factors will lead to demand variations that will cause the bullwhip effect to occur. So how do you counter it? Countermeasures. So there's 5 ways. The first is to align, number 1, align your goals and incentives to maximize profits across functions. Number 2 is to improve the accuracy of information. So sharing point of sales data and collaborative forecasting. Third is improving the operational performance. This is done by reducing lead time, basically. Or reducing the sizes of orders. Number 4, you can design price strategies to stabilize the orders. So for example, you can limit the quantity purchased during a promotion. And finally, you can build strategic partnerships with the other functions to reach goal congruence. Okay, so the last part is just what can happen to performance of a supply chain if there's a lack of coordination. So, for example, there could be shortages or back orders, excessive inventory, excess capacity, poor quality, and extended customer service, or long lead time, which will lead to just a longer supply chain. Okay, so that wraps up the final part of the review session. Is there any questions that anyone may have? No? Okay, so for those who haven't filled out the survey, it would be great if you can fill it out right now before you leave. Thank you. Good luck on your exam. Hi.
I go on the side.
It's funny, like this year, everyone's or they'll just be like, cool.
Yeah, okay, or, yeah,
Cut it all. Let's cut.
They were down two.
Actually,
They
oh my god.
because that was,
lost
Now, like, they said
They didn't even score, but
oh, it makes you glad because it's higher one.
Yeah, exactly.
Okay. So,
I just declined. I'm gonna do.
what's this?
This is the manufacturing cost.
Did they give that to us?
Yeah, it was in
Should I go?
Oh, so this is hard? Okay, so that's
So my
hard.
sister's gonna go. So
Hard 5.
This is like the very low.
Okay, the 3.5.
Yeah.
And this number is hard.
you guys have any of those forms?
Okay, and then the last
Do you guys have any
one
forms like that?
is
The surveys?
Yes.
Oh, online? Okay, that makes more sense. Thanks.
Is it? Should I just take a photo of this?
It'll be posted, but you can take it.
Oh, it's
It'll
gonna
be posted on the.
Oh, okay, then it's fine. Then I'll just read it.
I have a question for this. Why would you add this? It's number 3 and 4.
So you add everything under 5. So
So you're
under whatever your quantity is.
oh, okay, so you're supposed to add everything for that one.
Yeah.
I see. What if the cost? Why don't you consider the cost of this?